4.5, we're looking at graphs of sine and cosine functions. We're going to sketch the graphs of basic sine and cosine functions, use amplitude and period to help sketch the graphs, and then sketch translations of the graph of sine and cosine functions as well. So just to get the basic graph of a sine curve. So sine, remember, that represents the y value on the unit circle. So let's look at the quadrantals of the unit circle. So our y value, well, let's just do the ordered pair. This is 1, 0. At pi over 2, we're at 0, 1. At pi, we're at negative 1, 0. And at 3 pi over 2, we are at 0, negative 1. So the sine represents the y value. So we're looking at all these y values here. So at 0, here, 0, we're looking at 0 for sine. And then at pi over 2, we're at 1. At pi, it's 0. And at 3 pi over 2, we're at negative 1. Then at 2 pi, we're back at 0. At negative pi over 2, our y value is negative 1. And then at negative pi, we're at 0. At negative 3 pi over 2, we're at 1. And at negative 2 pi, we're back at 0 again. So looking at these values, we're going to go ahead and plot these points. So we have, I'm going to list this as 1 up here and negative 1 down here. So at 0, 0, we start here at the origin. Then at pi over 2, we're at 1. At pi, we're down at 0. And then at 3 pi over 2, we're at negative 1. And at 2 pi, we're back at 0. And then we can go backwards. So at negative pi over 2, we're at negative 1. At negative pi, we're at 0. At negative 3 pi over 2, we're at 1. And then negative 2 pi, we're back at 0. So this is our graph of our sine curve. And it just repeats over and over again. So the domain is negative infinity to infinity. You see that the x's go on forever. The range is between here and here. So that is between negative 1 and 1. It's symmetric across the origin. So therefore, hopefully remember this, that this is an odd function. So let's look at cosine. So cosine, we're looking at our x values. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So we are looking at our x values here. So let's fill in the chart. So at 0, we're at 1. At pi over 2, we are at 0. At pi, we're at negative 1. 3 pi over 2, the x value is 0. And at 2 pi, we're back at 1. At negative pi over 2, we are at 0. At negative pi, we're at negative 1. At negative 3 pi over 2, we're at 0. And at negative 2 pi, we are back at 1. So let me label our x-axis, our y-axis, 1 and negative 1. So for cosine, we start up at 1. And then at pi over 2, we're at 0. At pi, we're at negative 1. 3 pi over 2, we're at 0. And at 2 pi, we're back at 1 at the max. Then from negative pi over 2, we're at 0. At negative pi, we're at negative 1. 3 pi over 2, we're at 0. And negative 2 pi, we're at 1. So here is our graph of cosine. So the domain is the same as our sine function. It's from negative infinity to infinity, and the range is also the same, from negative 1 to 1. It's symmetric across the y-axis. You can see here, if I draw a line here, it's symmetric across the y-axis, so therefore this is an even function. So in order to sketch graphs of basic sine and cosine function, it helps to note 5 key points in one period of each graph. So we need to know the intercepts, the maximum points, and the minimum points. So for sine, we have the intercept at 0, then we have max, intercept, minimum, and then the intercept again. Now for cosine, notice that we start at the max, then intercept, minimum, intercept, and then the maximum. Full period is 2 pi. So when we list, what I like to do is start with the full period, 2 pi, divided in half, which is pi. Half of pi is pi over 2, that's the quarter. And then to get to the 3/4, that's 3 pi over 2. Okay, so what I do is I just add pi over 2. If you keep on adding it, so if you add pi over 2 plus pi over 2, that is pi. If you add another pi over 2, that is 3 pi over 2. If you add another pi over 2, that is 2 pi. So this is helpful when you're doing more complicated values, when it's not 2 pi. So for example, if it's 3 pi over 2 and you have to cut it in fourths, this is how I do it. You just take the first one and add it 4 times in order to get all those values. So let's try one. Using key points to sketch a sine curve. So this is asking us to sketch it between the interval of negative pi and 4 pi. We're sketching y equals 2 sine of x on the interval, negative pi to 4 pi. Let's just start with the period. Period of a sine is 2 pi, do 1 period. And so let's label our graph. So 4 out, that's 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. This last one is 3 pi over 2. Now I know I need to go to 4 pi. So 4 pi is here, and then 3 pi is here. This is 5 pi over 2, and then this will be 7 pi over 2. Then we need to go back to negative pi. So negative pi over 2 and negative pi. You can just mirror it from the positive side. So we know that our max is 2. So I'm going to go ahead and label 2 up here and negative 2 down here. I'm just scaling it just to stretch it out a little bit. So sine is going to start at 0. Okay, so that's at 0, 0. Our max value is going to be the next one. So at pi over 2, we're at 2. Then at pi, we're at 0. 3 pi over 2, we're at negative 2. And then 2 pi, we're back at 0 again. Okay, so we can list those points. Pi over 2, it's 2. Then at pi, we're back at 0. Then at 3 pi over 2, we are at negative 2. And the intercept, again, is 0, is 2 pi, comma, 0. Okay, so then you can finish the graph, right? We can repeat this to get the entire interval that it is asking for. There we go. And then finish the curve. Perfect. So go ahead and try this example here. Sketch the graph of y equals 2 cosine x on the interval negative pi over 2 and 9 pi over 2. And then also list the 5 key points starting from the y-intercept, please. So we tried this out, you would have gotten this graph here. So again, I started with just 1 period with here starting at the 0 and then go to the 2 pi, and then I just back it up and then go forward as to where it wants me to go. Of course, I label the x-axis with everything that I use and the y-axis as well. So just to finish it out, amplitude and period. The definition of the amplitude of sine and cosine curves. The amplitude is y equals a sine of x and y equals a cosine of x, represents half the distance between the maximum and minimum values of the function and is given by the amplitude absolute value of a. So it also talks about that a is what's called a scaling factor. And so we know that when a is greater than 1, it's a vertical stretch. It's a vertical stretch. And then when a is between 0 and 1, that is a vertical